fun time tomorrow night. You should all come watch the Tropics game.
Okay, so here we go on the second page of your homework. We just went over the first page, and then Peter so kindly reminded me to record.
You got that shout out.
All right.
Shout out, shout out.
Up here?
So take a look at this. We got a complex answer right here, and it's not going to exist
No real numbers.
in this function.
No real solution.
Okay, so keep on looking. See if you have any questions.
You only have to include the domain when you're dividing.
Correct.
Okay.
Now, when we do complete composition of functions, we also need to keep in mind the domain. Because remember, if there's a restriction on what we input, then there's a restriction
On the output.
Yeah. Ah, that's a good one.
This will be for number 30. We put negative infinity to -3 with the, not the bracket, but parentheses.
Yes, you can. I like it. Negative infinity to
Union,
-3, non-inclusive union with -3 to infinity.
Yay.
Good. All right.
So we only are doing real numbers, right?
Yes.
It's like the answer, like I just put like 4i root 2.
Incorrect.
It's not.
We don't need that.
You're asking that every day.
All right. So if we did a division and it looks like this, simplify it and give me the restriction. Okay, this is what you asked for. So we've done f of x was x squared plus 5x plus 6. G of x was x squared plus 6x plus 9. So when we start to do the division, it looks like this. Factor, simplify, and state the restrictions. There are restrictions on the domain of the function.
I'm singing French Christmas songs.
Well, you need to stop.
Just 5 or 6?
Okay, now third period, somebody asked, can we cancel the x's?
No, I guess not.
No, it's not negative. Or
Well,
never
it
mind,
would
don't
be the
leave
same.
it.
I think you
Well, it'd be
can. Because
Thanks.
x over x, it doesn't matter what you make it, it would still
So
be
it would
1.
actually, yeah.
Cancel or not cancel?
Can.
No.
We have a can camp. Who's in the can camp?
I changed my mind.
Mr.
I want to say yes.
Okay, so
Because that's
we
why
went
I-
from 1 to 3 to 1. Who's in the cannot camp?
Can I explain it?
I'm not going
We have
away.
6, 7, 8, 9, and the can't do it. 10 and the can't do it
Alright, Brian
camp.
can't, okay.
And we have some that either undecided or they didn't hear the original question.
Oh, I see.
So,
Can
all
I-
right.
have no idea.
right, now let me ask you a question.
If I'm right.
Let's pretend x were 7. Okay, can I cancel this and it equals 2/3?
No.
Oh, shoot.
No.
No.
It equals 1.
No.
Because it's like
It's actually
It's 9/10.
9/10, right? It's not equal to 2/3. So we can't cancel. This addition works as a grouping symbol. That x is stuck with the 2.
Yep.
It's not just x, it's x plus 2. This x is stuck with the 3. So the only time we can cancel is when they're identical. We have matching binomials. And we have to have multiplication. Here I had a power, but all a power is represented repeated multiplication, right? Okay, so this is a no-no. can't just go that. Alright, so let's erase that so we never get confused by that again. Alright. So today we're going to talk about functions and their inverses. Yes, ma'am.
Okay, just really fast on the last one. Like, I factor the bottom, but I don't factor the top. Is that wrong? Like, I just factor the
That
bottom.
makes it very difficult to simplify.
Wait, why do you have to simplify it, though?
Because that's part of the
I'm
division.
just going to take this to the left.
It's simplifing your fraction.
Oh, so you
That's like if I gave you a problem and you left the answer as 8 over 10. Would I be happy?
No, because it's
No, because that's simplified.
Okay, I'm getting
Are
some
they equal the same
answers.
thing?
I don't know why.
So we've got to factor the numerator
Okay.
and denominator. Now, guys, did you notice? I can't even remember if you got one on your homework or not. But sometimes we factor and nothing cancels. So did the factoring help us?
No.
No. So our original problem would have been our answer.
Okay.
But
So,
a lot of times when I come up with problems, they will simplify.
so if it doesn't simplify, you just don't write x does not.
Well, you still have to say what x. If there is an x in the denominator, there is a restriction.
Is it possible that there could be no restriction because the restriction or the
It's
thing
not
that was
possible.
external
Not
would
if
be
there was an X
imaginary?
in the denominator. If there wasn't an X in the denominator, we wouldn't be doing the problem.
I see what you're saying. I'll have to get back to you.
So I thought the curve was above the x-axis and it would never have an x-intercept.
Yeah, I'm thinking about what effect that would have on a rational function. Okay, so our inverses of functions are kind of what undoes the function. Okay, so
Big Tony.
I said I got it.
That's for Fahrenheit Celsius.
Try not to laugh. Oh, thank you, Danny. You're a good buddy.
Sit on her.
Yeah.
Big old bunch.
Alright,
Bunch.
I have a problem that models it outside right now, really.
we
Can I see what the temperature is on my phone?
we could go out. Yes.
Okay.
What? This is
I'm
the
doing
best
it really
day.
Okay, find the temperature in Fahrenheit, and we'll all convert to
Okay.
Celsius.
50 degrees on the dot.
50 degrees exactly.
On the
What
dot.
would that be in Celsius? Oh, that's beautiful.
Oh,
50 in Celsius, that would be,
No, 50 in Fahrenheit.
yeah.
Oh,
10
that's
degrees.
18.
That's
18 times 5 nights. 13 nights. 10 degrees Celsius.
10 degrees.
Hey.
Alright, so 50 degrees Fahrenheit is 10 degrees Celsius. Okay, somebody said 50 degrees Celsius. What would that be in Fahrenheit?
That'd be like
I'll be very hot.
That'd be,
That'd be really
I'm not leaving my house.
250.
That'd be
If
like
my house is still there.
That'd be 250.
That'd be, if we plug in 50 for Celsius, we get 10, so we get 90. Plus 32 would be
122.
122 degrees.
That's not
That's
bad.
what you
That's like
survive.
Arizona. That's like Arizona weather.
On like the worst day ever.
Your house would still
Boiling
be
point
there.
is 100
That's
degrees.
One time when I was like,
Alright.
your house wouldn't in my car, it was like,
Oh, she said in my house
Okay,
it's still
we're
there.
gonna stop and finish the lesson, then we'll have story time. Alright, so today we're gonna look at functions and their inverses. So, if we have one and we want to solve for the other, it helps to have these different equations, doesn't it?
Yeah.
Okay, so this symbol, f raised to the negative 1, that means the inverse of that function. The inverse of f of x. F inverse of x is another way you can read it. Now, we don't always write f of x or g of x or h of x. Sometimes we just write y. So if we were doing an inverse of a function that was just y equals, it would be y inverse. Okay? So here's this function, and we're going to find its inverse. And this is pretty simple. It takes 3 little steps. Step 1.
Write the function.
Okay. If you have not already written the function, that would be step 1. Okay, I was assuming you had.
Right.
Will it always be this one, or will it be another number? Like,
Oh, yeah, it's always a 1.
it's always
Yeah.
Is it 1 over 2x?
2x minus 6.
Whoa, slow down.
Ryan?
No, not exactly.
Right, right now.
I could
Alright, so our first step is to switch the x and y. Okay, so there's no real y, but what do we think of for f of x?
Why?
Y. So now we have x equals 2y minus 6. Step 2, solve for y.
X equals 2 minus 6. Interesting. This will be, you come to the tropics again tomorrow?
I'm not sure how to say no.
Not sure. I asked so
Alright,
nicely.
so you could have written it either way, right?
Yeah.
X plus 6 all divided by 2, or 1/2 x plus 3. Right? Don't these two things mean the same thing? Our third step is to indicate that it is now an inverse. And the way we do that is we're going to rewrite
Rewrite.
y using inverse notation.
Everything is negative.
I guess rewrite, replace, I'm not sure. So instead of y equals, it should say the inverse of f of x equals the inverse of f of x. So either way, so you indicate that this equation represents the inverse of this one.
So once you just change the sign on everything? Or was this something else?
That's all it is.
Oh, I know why you want to put it over 1 now. Because that's usually what an exponent means. Okay, so this is different than an exponent. Do you see how this -1 is contained within the function notation? The -1 within the function notation indicates inverse. A -1 as a power indicates 1 over that. Okay, I'm all clear now. Does that help y'all though?
Yeah.
Alright,
I
now,
don't
what I'd like you to do is sketch a graph of f and its inverse. Okay? And now do it nicely. Do it fairly.
Oh,
Right.
oh, thank you.
That was such a big...
Sketch f and its inverse.
I think it's just going to be dilated and moved down.
Oh, man.
Okay.
I love sketchy graphs.
Good. Why do we say sketch it? Just like your shoes.
I don't have sketchers.
What do you think I wear sketchers?
I think he was just trying to encourage you to do something.
Encouraging me?
No.
Oh,
You don't need encouragement.
Ryan, you're all good, man.
thank you.
Is that your dick again?
Yeah.
Stop.
That was Joel.
Snitch on all over, man.
Oh, it's
Those are little. I didn't quite right.
I love the way you immediately look for a relationship, because there is one. Think about accelerated coordinate algebra. Think about the transformations we study. It's a reflection over what?
Reflection over x. Or no, reflection over
It's
y
a
equals-
reflection over y equals x. Very good.
That's
So,
y equals x is when y equals.
Oh, I get it.
There you go.
Good job,
okay. So, what was our rule for this? When we did a reflection over y equals x, xy goes to YX.
Why?
Does that make sense with what we did up here?
Yeah, we
Yes.
Yeah, we switched.
Because it goes
So-
3, 4, 4, 3.
Yes. So all this, don't you love it when everything just ties back together?
Absolutely.
Okay, so here we go. I'm trying to draw it in. It's close, probably.
It's pretty much right on. Oh my
Alright.
gosh.
Yeah,
Like,
like,
just half of it.
So this is our reflection over y equals x, and that's what happens when we graph a function and its inverse. It's a reflection over that line.
All
Okay.
quadrilaterals.
So, here's the point. Here's the point 0, 3. Is the point 3, 0 right here?
Yes.
Here is the point 2, 4. Is the point 4, 2 here? Okay? So you see how if I gave you one graph, could you graph the other? Yes, because all you have to do is take the ordered pairs you were given and switch the x and y, right?
Yep.
Okay. Now,
We got it.
Wait. Okay.
now here's the blue one was the function, right? The blue one represents y equals f of x, and the red one represents
F of x equals
y equals the inverse of f of x. Okay? So that's the function, that's its inverse. Is the function and its inverse, are they both functions?
Yes.
Yeah.
Yes. How do you know?
Because they both.
They're both functions. They're both lines.
They're straight lines.
and they both
And they
go on
pass
forever.
what? What test do they pass?
Vertical lines.
Vertical line test. So the vertical line, to refresh ourselves, the vertical line test means I could draw a vertical line anywhere on the graph, and it would pass through no more than
1 point.
1 point.
You just take a ruler and like.
Okay, now,
Yeah, that's what I was thinking.
what if we only had the original function?
Well,
What if you only had this?
You could figure
You
out the
take
other
the
one.
y and put it in the x.
Then
Take
you-
the x and
okay,
put it
so-
in the
What
y.
if the red line wasn't there at all? How would we know if the inverse was a function?
Because
What's the inverse of
What are you thinking?
if it passes the vertical line test.
Okay, vertical line test tells us if that graph is a function.
Horizontal.
Horizontal line test. Is that what you were going to say? I'm so sorry.
Okay,
Okay, so when we switch here, what happens when we would switch on the vertical line? It would become
Horizontal.
horizontal line. So vertical line tells us if the original graph is a function. Horizontal line test tells us if the inverse of that graph is a function. Okay, now when we have a function and its inverse are both functions, they aren't always, but when they are both functions, they are said to be
1 to 1.
1-to-1. So, a function is said to be 1-to-1 if the function and its inverse are both.
What is 1 to
Function.
1?
What do you mean 1 to 1?
1-to-1 is just how we name it.
What does that mean though?
Yeah. That's just how you name it. Name one.
You guys attend Starsville High School, therefore you are Panthers. What does that mean?
No, we are not losing.
It's a designation for Starsville High School students.
There's no losers.
Okay.
Panthers.
If a function and its inverse are both functions, it has a special designation called 1-to-1.
Okay, that makes sense.
Are you recording?
I actually like putting time.
Were you recording?
Yes.
Oh, I hate
Everyone's like,
Alright, and then this is the other thing we talked about. If you only have a graph of the original function, f of x, not the inverse, you could use a horizontal line test to determine if the inverse is a function. Yes, John?
can you explain the horizontal line test?
Horizontal line test? Sure. Same thing.
John, you just
Passes
showed
through
me what
what
it was.
line?
Okay. So,
No, I don't understand.
there is a horizontal line. And the blue one was our original function. No matter where I place a horizontal line on that blue function, does it ever go through more than 1 point?
No.
No. So this horizontal line test tells me that the inverse of this blue function is also a function.
So quadratic
Well, we
is
can-
the equation here?
So would a quadratic the inverse of a quadratic be a function?
Yes.
No.
Because it passes
No.
away.
Just this.
But- But what could we do to a quadratic? What could we do to its domain?
Which is
Restrict it. If we restricted the domain of a quadratic to either the left side of the axis of symmetry or the right side of the axis of symmetry, then the inverse would be a function. And you're right, it's a square root function.
Eight.
Whew, this is
You
good
wrote
stuff.
the twice on the last
I wrote the twice.
Yes.
Oh.
It was
You
so
can-
pretty.
You can use the horizontal.
Okay, thank you.
Wow.
Thank
Thank
you.
you
No,
I'm
no, no.
surprised actually I didn't even saw that.
Wow.
I need an editor, that's for sure.
Okay, Matt has the job.
No.
What's the girl's
Just look at words on it.
So will we ever
We have
have
to
like
look
an
at inverse.
equation that's not a function but the inverse is?
I sure all of this.
You?
Probably.
Could you draw a picture for me? Could you think of one that is?
Alright.
Alright. So let's look at this one. Is the original graph a function?
Yeah.
Yes.
Yes.
Would its inverse be a function?
No.
No. Is it one to one?
No.
You know what? I'm with you. Let's make up another name.
Wait,
We'll
are
be
we
famous.
Are we really going to
Okay.
it too? Though?
No.
Is this graph a function? Yes. Is its inverse a function? No. Is it one to one?
No.
No.
1 to 2.
1 to 2.
I said that, well,
Yes,
actually,
Is
that was-
this graph a function?
Yes.
Is its
Yeah,
inverse a function?
No.
Yeah, it is.
Oh, yeah.
Good job, Brian.
I guess I kind of meant for this to keep going up.
Okay, well, if you did that, I saw it come back around.
I got
thought,
you.
Oh, okay.
I
Yeah,
It's
it's
like,
lies.
what the-
Alright, there we go. I corrected it.
It was
Isn't that like a 1
Okay,
X?
and so yes,
Not 1 to 2.
Brian's just trying to save himself.
could you draw the inverse?
Yes.
Yes.
Just
How?
shoot.
I don't want
Go
to.
on the other
So-
way.
You just
X
goes
You
up
auto
2
work.
over 2. It
You
would
go to the X value.
it would be the opposite
Good.
of that.
Good. Alright.
Then you would divide that on. Yeah.
So you
Just leave X and Y
Alright.
and flip.
Alright, good.
Mention Jake, right?
Okay. So let's get back to actually finding the inverse. Now that we know everything we need to know, let's go back to step 1.
3x minus 5.
No, you
I like it.
Mateus, find the inverse. Go.
Watch.
Mateus, find the inverse. Go.
Your son
Alright.
take
I don't want to do number 3.
But do you take order?
Oh, we have to do number 3 too.
Number 3 is easy.
Oh, is it and
Just do number 1.
I'm
Alright.
all papered out.
I'm going to keep going because,
Jake, what's it?
You're invited to the shop escape.
Whoa.
hey, is there any restriction on the domain of the original function?
No.
No.
No, it's a lie. Is there any restriction on the domain of the
Yes, negative
inverse?
50.
Haven't gone that
Or,
far.
well, on the
Right.
second? Number
Was
3?
was there any restriction on the domain?
Oh, I thought
or
you said
range?
number 3.
Okay, on number 3,
Number 3,
yes.
yes.
Okay. So Ryan's already working ahead,
Yeah,
and he is ready for number 3.
Sorry.
Let's call
No,
this Gia.
Ryan, that's a good thing, man.
Wait, I'm not
Alright.
ready for number 3.
Well,
Okay,
hurry
you're
up.
the one that yelled out the answer for number 2.
Yeah, but I thought we were. You know, shut up now.
Joel, just
That's the first thing I've
That's all you
understood
have
all
to do
year
for
long.
number 2? That's
all
all
you
you
have
have
to
to do.
That is not the truth.
Well, I feel like you've said that
Yes,
before.
it's going to be all you have.
Alright, let's talk about the domain of g of x. We talked about a square root the other day, so I think you probably have an idea. What is the smallest possible value for x, John?
the smallest is
1.
well, that's the largest.
So it goes from 1 to
Infinity.
infinity.
Are you okay?
Or don't worry.
Hold on,
I'll-
stop.
Okay, quit drinking. You can only have water in them.
I was drinking water. No, I was actually drinking water.
She has 3 different drinks.
Okay, so we know 1 is our first point, our first x value. So if we plug in 1, we get out 0 minus 3 is negative 3. That's not 1, negative 3.
You
There we go,
multiply.
our first point. Okay,
Yay.
now, so we can plug in anything after 1. Would 2 be a good choice?
No.
No. Make it
Why
a
do y'all
square
say
root.
things without even looking?
Yeah, just square root.
If
You gotta
we
make
plug
it a square root.
in 2,
Because then
Oh, because then
it's
it's square root of 1 and then you can multiply. Oh,
Alright.
yeah.
so if we
Alright.
plug in 2,
5. Next one is 5.
we get out negative 1. Okay, and you're right. Our next choice for a value we would plug in for x would be 5. Because that would give us a perfect square under there after we perform the operation. So that would give us 4. Square root of 4 is 2. 2 times 2 is 4. Minus 1 is 1. Minus 3 is 1. Okay, so that's my graph.
What
Alright.
is that
On
graph?
most of these problems are
This is a square root function. Alright, now that we've kind of sketched out the graph, talk to me about the range.
Negative.
It starts at
It starts at negative 3 and then goes to positive
Infinity
3.
to positive.
I'm gonna show.
Do you see where it came from in the function?
Yes.
I want
The
it.
y-intercept.
Remember our
So you plug in-
transformations? That does our shift up or down?
And then you can
Okay.
plug in 0 for x to find it.
Yeah.
And then,
Okay.
then you just-
Do you know how happy this makes me?
Think inverses.
Thinking.
Okay, with an inverse, what do we do with our x and y?
You switch them. So it's going to be
What effect does that have on the domain and range?
Reflect
Swap
over
them.
y x equals x.
Flops them.
Okay, so we know with the inverse, we have a restriction on our domain that goes from negative 3 to infinity. And we know with that restriction on the domain, the range would go from 1 to infinity. Okay, let's see if you can find that inverse. What is it? Find it.
Get it, boys.
Would you multiply the 2 out before you do the square root?
I want to see what kind of equation solving skills you have.
I added
Show off your
This one, I
skills.
totally
I
got it.
added the 3 to
Absolutely
the other
got it.
side. So that was pretty good.
Wow.
I would try, Miss Sylvie.
Good.
I think I got it. I think I really missed
I don't know what I'm talking about.
Y.
I just flipped the X and Y.
I think I got it. Oh, I don't have to square every part of that. Hold up. I messed up.
Yeah. Because it has a, I don't know.
Yeah, you solve for y.
Oh, man.
I was going to do that.
Lies. We weren't gonna do that until you looked
Ooh.
Call it out.
No way.
What was that?
OMGM. That was
Alright.
deleted.
You should have gotten x plus 3 over 2 squared plus 1.
That's what I got, Miss Sylvie.
Now, this is what kind of function? Because you know we did a whole unit on them.
Oh, yeah. We
Oh,
were supposed to move the...
Quadratics!
Thank you.
Yeah.
Thank you.
Sorry, I
Okay.
just had to say it.
It's a quadratic function with what kind of structure compression?
Restriction. Oh. It's a dilation.
A
Left horizontal.
Horizontal
Horizontal stretch.
stretch
Yes.
by a factor of
2.
2.
I was gonna say
And
that.
a horizontal shift,
Of 3.
3. Negative 3.
1.
negative 3.
Yeah.
And a vertical shift.
1.
One.
Okay, good.
I was thinking of the verb.
Hey,
Joel, you totally
But-
did wrong,
what does this domain do?
though. Can't go...
This domain only gives me which side of the parabola?
Left side.
Right side.
Right side.
Hey.
Right.
Right
Sorry,
side!
not left, that's
Oh
the
my
left side.
goodness, guys. What?
Oh, okay, it's a reflection.
So-
Now, if
you can write the whole
this is
parabola
1,
together.
negative 3, then this would be negative 3, 1. If this is 2, negative 1, this would be negative 1, 2. If this is 5, 1. This would be 1, 5. So, do you see how it's the right side of the parabola?
I've seen those before.
Really? Where?
Yeah, right here.
I'm stuck in our home and it'll go like this.
Yeah. Now you know why.
She was like, yeah,
Guess what?
Okay. Does it appear to be a reflection over what it was at?
Yes.
All right.
Here's just
I would live
Okay, so key.
Oh my god.
The key
It's
to
on the-
this
it's probably a reflection of white.
is the restriction. Because without the restriction, would,
No.
no, this would be a whole parabola. We gotta restrict. Okay,
See, why do you actually have to solve it if you know that it's like the reflection, then why can't you just like do the opposite points? Why do you have to-
sometimes I won't let you graph it. Sometimes it's all algebraic.
Yeah.
Yes, ma'am.
So I know how you found the range restriction. So how did you find the domain? It's just on the inside, right?
These swapped.
No, I mean for like how did you find it originally? You just
The
those two
range,
numbers, right?
the domain?
if it's positive, it's going to open up and shift it down 3. So negative 3 to infinity.
And then the domain is just one.
This can't be negative. You can't take a square root of negative.
Right.
So it's from whatever makes this 0 to infinity.
Double word.
All right. So we're going to revisit our first example. And we're going to prove that these are inverses. Now, yesterday we learned composition of functions. Today we're going to use composition to prove that functions are inverses. So if I were to take f and plug in its inverse, every time the result should be x. So if I took f and plugged in the inverse, okay, what happens to the 2's? They cancel. So I'm left with x plus 6 minus 6, which equals x. I'm left with x. Or, if I go the other way, if I plug the function into the inverse, the same thing should hold true.
Cancel. Oh my god.
So I get 2x minus 6 plugged in right here, plus 6 divided by 2.
Plus.
Well, those cancel.
That is magic.
And then those cancel,
Plus
and I
you
get
can
x. So if I gave you any random function f and another function g, could you determine using composition
Yes.
if they are inverses?
Yes.
Yeah, plug g into f, and what should we get? The result is x. We already knew these were inverses. We solved it, we graphed it, we know several ways they're inverses. They a very special kind of inverse called what kind of function?
1 to 1.
1 to 1. All right, your homework. Is that in your textbook?
Let's get it, boys.
All right, now let me explain this. On these 3, you're going to algebraically find the inverse and then sketch both the function and its inverse and tell if it's 1 to 1.
Gotcha.
Then follow the book directions for everything else.
Oh, that's a lot.
You have an opportunity to come very close to finishing, if not finish your assignment before the bell rings.
That was done.
That's boy.